Hello from San Diego, where we survived our tsunami advisory. A tsunami advisory is like the middle one. There's tsunami watch, where it's basically like, watch out. It might come to you, but it probably won't. Then there's here tsunami advisory, where it's like, the tsunami is coming, but you're going to be fine, basically. Like, stay out of the water, stay out of the harbor, but otherwise you're fine. And then there's tsunami warning, where Hawaii was, where it was like, get to higher land, get a mile away from the coast if you can, or 100 feet up if you can. But you might have seen in Hawaii, they did something that seems very counterintuitive, which is that if people were on a boat, they went out to sea. This seems absolutely insane, especially if you grew up in like hurricane country. Why would you go out to meet the tsunami? But this is exactly what you should do, and this is why. This is the science behind why you should do that. So a tsunami is not a storm. It is actually just a collection of waves. So it's caused by some geological event, in this case an 8.8 earthquake, but it can be caused by a volcano. It can even be caused by like a huge rock slide or landslide. And then that geological event, like boom, earthquake, causes a ripple, multiple ripples actually, of waves. Those waves cross the whole Pacific Ocean. And as oceanographers, there's like multiple ways that we measure waves, but we measure them based on their like wave height and their wave length. And so these tsunami waves are like specifically important because they have really long wave lengths. They're crossing the whole Pacific, but relatively short, what we call short wave heights, because that wave height is measured as the height of the wave relative to the depth of the water. And they are crossing the entire Pacific, which in the middle of the Pacific, it is like 9,000 feet deep or 10,000 feet deep. And so the wave is like really short. We consider these short water waves, even though they're huge tsunami waves that are crossing the whole Pacific. And so they have these really, really long wavelengths, these like long crest and trough periods. They can be like 15-minute crest to crest periods. And then what we consider these short wave heights relative to how deep it is. And so that's important for a couple reasons. One, it means that the wave can travel really, really fast across the Pacific. It can travel at 500 miles per hour. That's basically as fast as an airplane can travel across the Pacific. It means, two, the most important, it can travel really fast without losing any energy, or relatively any energy. And so the wave keeps all of its energy and momentum as it travels across the Pacific, because that wave height is pretty short compared to the bottom. And so it's just like, don't mind me, I'm just gonna travel across the top. And three, this is why the people in Hawaii went out to sea, because if you are out to sea, you're just gonna feel these like short waves, long wave heights. It's just going to be like burp, burp under you on a boat. If you're on a cruise ship, like way out to sea, you wouldn't have even known necessarily a tsunami was under you, which is kind of crazy. Okay, so then why are tsunamis dangerous? Because what happens is when you're not in the deep, deep part of the Pacific, but you come to shore and the beach is like this, when the beach is like this, the wave, those long wavelengths start to hit that shallow beach. All of a sudden, those long wavelengths hit that and they get shorter. And that short wavelength, it gets higher because all that water still has to go somewhere. And so that long wavelength and short wave height, it basically starts to pile up, and it piles up on top of each other. And that all of that energy that got that wave across the ocean with it basically without dissipating any of the energy, all that energy builds up on itself. And so that's why these waves are so powerful and so dangerous once they hit the coast, because it's actually the coastline, the shallow, shallow coastline, interrupting this like long, shallow wave. And so that's why boaters are recommended to go out to sea, because they're actually going to ride like the calm wave before it interacts with the shallow coastline. And if they stay at harbor, if they stay in the marina, if they stay near to shore, not only are the waves going to be a lot rougher, there's going to be a ton more water surge, they're going to hit those waves, but their actual boat is not only going to probably get damaged, but their boat is going to then be hit by those waves, and their boat can become actually like a piece of debris, a like missile almost in that wave surge. And a lot of the damage that happens in a tsunami is when those tsunami waves hit flying debris or hit floating debris. And take those boats, and then it wouldn't just damage the boat, but it would damage the marina and any of the neighboring like hotels. So they're asking them to go out to sea, not just to help the boat, but also to like help the neighboring hotels, that they don't just like have a boat flying at them as the wave goes into shore. Okay, why would you never do this in a hurricane? Because a hurricane isn't just a huge wave coming into sea. A hurricane is a storm system. It is an atmospheric storm system. And so there is atmospheric pressure, there's the eye of the hurricane, there's rain, there's wind pressure, and there's waves. So there's so much more going on that a little boat could get caught in besides just a wave going under you. You would be battling the entire storm. You would get soaking wet, all those things. So never sail out into a hurricane to try to ride the hurricane out, but you can sail out into a tsunami. Hope that helps.